Back. Today we're going to talk about confidence intervals and making them for a set of paired data. I want to actually pop down to this example before we start talking about the notes part up here under the important ideas so you can kind of see like where the idea of paired data comes from. So check out this example here. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the caffeine in the placebo was randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression at the alpha equals 0.05 significance level. Okay, so check this out. Think about this experiment for a second. How many participants are there? Are there two groups of 11 and you're comparing them? No, there's one group of 11 people and they are being subjected to both treatments. So when we talk about paired data, why would this be considered paired data? Because me as a person, if I'm one of the participants, I'm one person receiving a pair of treatments. And so it's not two people being compared side by side, not a matched pairs experiment, but this is paired data because it is one person getting both treatments. And so we're going to come back to that, but I want to talk about a couple of the important ideas here just real quick. So first, we need to be able to describe the distribution. This is a lot like any other distribution, but what we're looking at is they wanted to know whether being deprived of caffeine would lead to an increase. And so we're comparing one treatment to the other. And so when we're describing distributions, okay, we're going to have a number line here, right? In the middle is going to be 0. When we're making this comparison, we're subtracting, right? And so the possibility exists that we have some negative values. The possibility exists that we have some positive values. If it falls this way on our distribution, then that would mean the second is larger. Right? Because if it's on the negative side, right, that would mean the second one was bigger. If it falls on this side, that would mean the first is larger. That distribution is going to give me a little idea of where most of my data falls. And so what I'm actually going to be comparing is one of two things, right? So I can either compare the average difference of x bar, or I can compare some other things about this data. But the two pieces of data that I'm going to be using to make some of these assertions is the differences in each of them. I'm going to find that mean difference, which is going to be that x bar difference. And I'm going to find the standard deviation of that difference, meaning comparing all of the differences to one another. And when I'm doing my write-up, my mean is going to be equal to my mean difference here for all of those values, but I'm just taking a sample of people here just to see what happens. So what is the test that I'm actually doing, or what is the procedure that I'm actually doing here? It is going to be a one sample because I only have one sample of people, right? I have 11 people. A one sample t interval and why is it a t interval? Well, because we're dealing with means still. One sample t interval for the mean difference. Okay. And my sample difference here, if I'm making an interval, that sample difference here is going to be my point estimate, and I'm going to do plus or minus again, T star times standard deviation of my data set over square root of the number of people that I have in my particular study. So let's just take a look here. So the data below contains the data on the subject scores in the depression test. And let me grab another color here. So make a dot plot of the difference in depression test scores, caffeine minus placebo for each subject. What does the graph reveal? So I'm going to make a dot plot of the scores. That's going to be what I was talking about up here, right? So that's going to be my describing the distribution. So if I've got caffeine minus placebo, I need to do my differences here. So 5 minus 16 would be minus 11. 5 minus 23 would be minus 18. 4 minus 5 would be 1. Minus 4. Minus 6. Minus 18. Minus 6. Minus 3. Minus 13, minus 1, and 1. Okay, if I'm going to make my dot plot here, let's take a look at what's going on. Draw down here. Get as straight a line as possible. There we go. And in the middle, it should go 0. Well, just take a look. So when I'm constructing this dot plot, I have a lot of negative values. So I'm going to put my 0 right here. And this will be negative 5, negative 10. Okay, let's put some data on this chart. Grab a different color here. Okay, negative 11, negative 18, 1, negative 4, negative 6, another negative 18. Oops, I think I put a negative. I put it in the wrong spot. Erase that. Okay, negative 6, negative 3, negative 13, negative 1, and another 1. Okay, so where's my distribution? Looks like most dots are negative, meaning what? Meaning that the placebo score was higher. So most dots are negative. So placebo score was higher. So if most dots are negative, placebo score was higher. That's just a generalization. Let's put some math behind that. So find the mean and standard deviation of the difference of caffeine minus placebo in depression scores. Interpret the mean in context. So again, this is a small list, right? So I could do my mean, but if I go put all my data into L1, and then I do my 1 bar stats, that's going to give me my X bar, and I need to label this because this is X bar of the difference. And when you put that in, now this is a great place to pause, right? So pause, put that in. Don't fall asleep thinking that, oh, I know how to do that. I know how to put it into L1. I know how to find 1 bar stats. Actually put it in, actually try it. So when I put that in, and so you could pause here and do that and check your answer. When I put that in, I found that my mean difference was negative 7.364. And the standard deviation of my difference was equal to 6.918. Okay, so the average was negative 7. The average for the sample, so the sample mean was negative 7.364, and my sample standard deviation was 6.1918. So interpret the mean in context. It means on average, the placebo score, and there's a couple ways to say this. So you could say the placebo score was higher. You could say the caffeine score was lower. I'm going to say on average the placebo score was 7.364 higher than caffeine. Okay, on average, placebo score was 7.364 higher than caffeine. So construct a 90% confidence interval for the true mean difference in depression to test score caffeine minus placebo. So this is a state plan do conclude kind of a situation. We already stated what we're doing. So we're doing a one sample T interval for the mean difference. Our plan is to we're going to state, so the mean is equal to the mean difference. The plan is to do this one sample T interval. Let's do the do here. Let's actually just do it. Our formula is our point estimate plus or minus our margin of error. And that would be our X bar of our difference plus or minus T star times standard deviation of the difference over the square root of n. And when we actually do that, we have our values here, right? So we have negative 7.364 plus or minus. Now T star, where do we get that? So our T star comes from this 90% confidence interval, and that's going to be our 1.812. Comes from our table B, right? So our degrees of freedom and finding that 90% confidence interval. And then on top goes our 6.918 square root of 11. This is a great time to pause here, right? So a great time to pause and put this math in. Great time to pause is always, I put in that formula and see if you can fill it in, especially when finding those T-star values. This is a great time to practice finding those T-stars using your table or your TI product or your calculator. Okay, and so up with when we do these computations here is we end up with an interval that goes from negative 11.144 to negative 3.584. Okay, so that's a 90% confidence interval. So check out what that means. We have two negative values in our interval. Think about what that means. Is there a possibility that the true mean is 0, or that there's truly no difference? Well, 0 is not in that 90% confidence interval. So that's significant there. So let's do our conclude here. Okay. Now we only did the do and the conclude portion, but we have this plan, right? We made this confidence interval, this one sample confidence interval for the difference of means. We have no outliers, right? So we have this plot that shows no outliers. So that's our normal. We have a sample size that's appropriate. It's the 10% condition. And so I didn't go through all 4 steps. We just kind of cut to the chase. But this would be one where you could go through all 4 of those steps. Let's jump down to this conclude portion. So conclude. Conclude. Now this is that verbiage that we've been using for quite some time now. We are 90% confident that the interval from negative 11.144 to negative 3.584 captures the true mean difference the true mean average, sorry, the true mean average difference. And that's important because look at what we use for our point estimate here. That represents the average distance, right? So the true mean average distance difference in depression scores. So we're 90% confident that the interval from negative 11.144 to negative 3.584 captures the true mean average difference in depression scores. Okay. Once again, to review. So when we go up to the top, why is this a confidence interval for paired data? Why is this paired data? This is paired data because it has to do with one person doing both things. So anytime you're pairing data in that way, this is the kind of setup that you're going to use. You're going to find the average difference using all of the differences from each of the subjects. So we have 11 subjects, but one person is doing two different things. And you can see why in this case with this caffeine experiment, this would be a good way to set this up. So that's the basic gist of setting up a confidence interval for paired data. Should look very familiar. The type of data is going to dictate what we do, but then from there, when we execute these, you are still doing that point estimate minus plus or minus that margin of error. And that's the kind of thing that we're working on, guys. So thanks for watching, and we'll see you next time.